Today we will be discussing variables. Your computer is a goldfish and doesn't remember anything for more than a few microseconds. And for you non-science people, that's like a millisecond of a millisecond. Variables are a way to store things in your computer's brain, at least for a little bit longer. Now, to do different things, you need different types of variables. You wouldn't download a car, would you? No, because that literally doesn't make any sense. You steal a car and download music. Both legally, of course. In that same vein, you can't literally add letters or divide integers until at least first grade. So there are a bunch of different types that were given as a starting point. For more complex types, we'll make them ourselves. Later, you overachiever. To start with, we have our primitives, which are all lowercase and become shinies in your IDE when they're typed. These are a
tale as old as time, song as old as rhyme.
For our basic ones, we have our integers, our Booleans, which are a fancy programming word for true-false, characters, and the double, which makes no dang sense from a naming convention, but it means it has a decimal value. There are a handful of others that are variations on these, but don't worry too much about them just yet, as they're just different ways of storing the same values. I'll cover them in a later video, but for most cases, you won't really need to worry about them too much. Now, we're going to mess around with these variables and types a little bit just to get a feel for them. Do you want to do math? No? Well, that's perfectly normal. And just like your teachers back in school, I don't really care, because you're going to do it anyways. So let's do some math. First, we're going to create a couple of int variables and give them some values. So let's start off by typing out int a equals 1, int b equals 2, and now we're going to make a new variable called int c, which is going to equal a plus b. And you'll never guess what value c has.
Who's that Pokemon?
It's 3! And we can actually use that system.out.println from the last video to prove it. And we were right! Subtraction and multiplication work as expected too. But where things get a little tricky is with division, because most, but not all, programming languages don't like having to think. An integer is an integer, and for a lot of integers, dividing by another integer means you get a fraction, not an integer. So remember how if you had 11 divided by 5, you could rewrite it as 2 and 1/5, or 2.2? Computers sort of think like that, but then they go integer, and just drop all the non-integer parts of it. So 11 divided by 5 actually equals 2. You were right back in elementary school. Now you can go and find your elementary school teacher and tell her that she, or he, was wrong and that they should sit in the corner for crying. But what happened to that 1/5, you ask? Well, computers have a special symbol that handles those little leftover bits of numbers called modulus. It looks a lot like a percent symbol, but it's very different in that it has a different name. See? Modulus, percent. Very different. They don't even share any of the same letters. But what modulus does is it takes that remainder that division just threw away and says, hey, that's actually me. But again, it still wants to be an integer, so you need to convert your 1/5 fraction into an integer. Well, how do you do that? You take off the top number and call it a day. So in our previous example of 11 divided by 5, where you had that 1/5, you do 11 modulus 5, and it equals 1. Done! Now, for doubles, everything works exactly like you learned in school. So 11.0 divided by 5.0 equals 2.2. And if you mix an integer and a double, the computer just assumes you want a double and gives you a double as a result. So 11 divided by 5.0, or the other way around, still gives you that 2.2. Small caveat for numbers in general, computers have a bad memory, like I said earlier, so they can't really remember too many things at once, which means that things like integers and doubles do have upper and lower limits. Those will matter in the future, and are where those variations that I mentioned earlier come into play. But for now, just know that they are a quick Google search away, if you ever need to know right now. But I will have a full video in the future going into what they are, how they're different, and why they are different, so don't worry. Next are characters. They are just single letters, numbers, and symbols. Everything from lowercase letters to a $sign. There are a few different representations of them because people are dumb and thought Roman letters were the only ones that mattered until they remembered, oh wait, there's other alphabets. But we will focus on the Roman ones for now, since those are the default and simplest. Those are called Ascii, and there are 256 of them. And they are numbered from 0 to 255, because f*** you, that's why. But also remember that 0 is the first real number, because that's actually going to be a hugely important thing in programming. All these characters actually have a corresponding number as well. For example, an asterisk is actually the answer to the ultimate question of life, the universe, and everything, i.e. 42. And you can actually do some pretty cool things with the fact that each character has a corresponding number. But for now, just remember what the characters look like, and that they use single quotes. And the single quotes are important for denoting character. Double quotes are for strings, which are really just a bunch of characters all together, like in our Hello video print line. Which actually brings us to an interesting little type named strings. They are capitalized, unlike the other types so far. They are effectively a combination of characters and put in those double quotes. They are actually really powerful, but have a lot of nuance. We'll get into those nuances later, but for now, just be aware that some symbols are very special, like quotation marks, apostrophes, and your slashes. They might cause some issues down the line, so we're going to keep things simple and just try to avoid them for now. Lastly, we have Booleans, which are ways to track your yes-no results. They are the simplest, but also the hardest. Kind of like life. If something is true, you can have Boolean t equals true. If you want something to be false, you can mark it down as Boolean f equals false. That's pretty simple. Okay.
You can't handle the truth!
So we will try to reassign b to be false. But in Boolean land, there is a way to negate something called not, which is an exclamation point. So if we type system.out.println exclamation point t and then run it, we'll see that it prints false. Still not too hard. You have true, false, and a way to switch between them. But now it starts to actually get a little bit harder, because you have to actually be able to combine your Booleans together. These Boolean operations, or Boolean math as they're also known, are and or, which can be represented by two and symbols or two vertical bars. And your vertical bar button will most likely be right above your return key, since it's not something you've probably ever used before. Double and means both need to be true for it to be true. Double bar means one or both need to be true for it to be true. So simply, true and true equals true. True and false equals false. True or true equals true. And true or false equals true. These are the basics of Boolean logic, and it gets way more complicated. But from here on, we can slowly build up to there, so if it's confusing, don't worry. Schools go over this concept for a whole semester, or even 2, to help you get good at it. You can even get a math PhD focusing in on this stuff. But if you want me to create a dedicated video on Boolean logic sooner rather than later, let me know below. Okay, so we have covered the core types in programming. These will be shared by pretty much every language in some way or another, and are the foundational building blocks of our Lego puzzle of a new hobby. From these, all things flow. Like, subscribe, and comment below what you want to see next or topics you'd like to know more about.